We are in Algebra 2 on this beautiful Tuesday, November 13th, 2018. So do put the date. Today's date is 11/18. 3-7, Polynomial Remainder Theorem. This is a cool theorem because it's a shortcut of the shortcuts related to synthetic division. So we love the shortcut. It's a cool theorem. You should know it. Let's talk about the theorem and let's talk about what it means in ordinary English. All right, so who wants to take a shot at trying to read that first two lines? Uh-oh, that's not good. Who can read these first two lines for us? Go for it, James.
F of x is a polynomial and is being divided by x minus a, then the remainder will be f of a.
Perfect, yep. That's the theorem, and that's already as simple as I can make it in terms of the formal theorem. But here is what it means. So if I have something of the form x plus or minus a, and that's the same form for synthetic division. If you remember the form for synthetic division, it was this. It was x plus or minus some number. Nod your heads if you remember this. No one nods their heads. So in synthetic division, we had something of the form x plus 1, x minus 8. Something like this. Then we were allowed to use synthetic division. Now nod your heads. Does that bring back some bells? I get over half of us nodding our heads. If you have that form for synthetic division, then you're also allowed to use the polynomial remainder theorem. What that basically says is take the opposite. The opposite of negative a is positive a. Take the opposite and plug it in. The opposite of negative a is positive a. Plug that into your original polynomial. That will be your remainder. It's a quick way to find the remainder. So, if you are dividing by x plus 3, plug in negative 3 and that will be your remainder. We're copying this down, right, Chris? We're not so hilarious over there that we can't copy down, laughing so hard. Tom is using his ability of joke, makes you laugh so hard you pee, 45 damage. So we have our ordinary English, perfect. Let's see how to use that. By the way, if you have a remainder of 0, what does that mean? Like 6 divided by 3 is 2, remainder 0. What does that mean in terms of divisibility when I have a remainder of 0? It's kind of a conceptual question that I'm throwing at you guys. Again, the question, when I have a remainder of 0, what does that mean about the divisibility? Only Andrea knows? I'm going to repeat the question again. Think about this question. When I have a remainder of 0, what does that mean about the divisibility? Still, only Andrea knows. Eva kind of knows. Gio kind of knows. Fiona kind of knows. Andrea, go for it. Yeah, it goes into it evenly, right? 6 divided by 2 means that 2 goes evenly into 6. If I did 6 divided by 5, all of a sudden, hey, 6 doesn't go, or 5 doesn't go into 6 evenly. It means that it's divisible. Okay, so let's go on to example 1. What is the remainder? Oh, if I'm looking for the remainder, I know that I can have the theorem that we were talking about, the polynomial remainder theorem, to just quickly get to the shortcut of what the remainder is. When I'm dividing by x plus 1, oh look, it's that form that we're allowed to use for a synthetic division. That means we can use the polynomial remainder theorem. Let's go ahead and do that. The opposite of positive 1 is, shout it out, negative 1. So let's plug in negative 1 into each of these x's. Everywhere you see an x, plug in negative 1. This is how you write it. P of negative 1. By writing P of negative 1, you are saying to me, you're saying to yourself, you're saying to your neighbors, I am plugging in negative 1. Here I go. By plugging in a negative 1, I get 3. Why so much lag? 3. And then here's my negative 1. And that is still to the power of 4. Then I'm going to subtract 5 times that negative 1 to the power of 3. Then I'm going to subtract 7 times that negative 1 to the power of 2 plus 4 times that negative 1 plus 3. All I did was in the place of x, even this x right here, I just substituted in -1. So far, so good. That was easy, Mr. Sindel. Let's see what actually happens here. This is a little bit of a review of what happens when I take negative numbers to even powers. Hopefully you remember that. Or odd powers. Hopefully you can remember. And that's why we're doing the review. Okay, I need to know what -1 to the power of 4 is. Is that -1 or +1? You have a 50-50 shot. What is it? How about you do it with your fingers? You can go like negative, I guess from your direction, -1 or +1. It is +1. Whenever you have an even exponent, it's always going to be positive. So you can say something like this. On your notes, if you forgot that, you say a negative to an even equals positive. A negative to an odd equals a negative. There's your quick little shortcut. Now you always know if it's going to be positive or negative, and then you actually have to do the math. Sometimes I'll say 2 to the power of 4, and you say, oh, I've memorized that's 16. You will have to do some big multiplication on the homework, just be warned. I think even on here you have to do, 5 to the power of 3, so you'll have to be able to calculate some large things. So -1 to the power of 4 is a positive because it's an even exponent, so 1 times 3 is shouted out.
3.
Yeah, Andrea knows what's going on. Everyone else, maybe not. I'm worried for the rest of us.
What?
So P of -1 is equal to 3. Okay, now here's the question. -1 to the power of 3 shouted out is? -1. Yeah, because it's now an odd number. And now what is -1 times -5 shouted out?
5.
Andrea's lifting this class on her back.
You're going way too fast.
Okay. No,
He's really
I don't
strong
care.
anyway.
I'm going to pause here because I have a student tell me I'm going a little bit too fast, and that's fine.
Go now.
-1 to the power of 3 is -1.
Got it, yeah.
-1 times a -5 is a positive 5. I'm going to write a positive 5. All right, you know what question I'm about to ask. It's something about this -1 and 2 over here. Here comes my question. -1 to the power of 2 is... Gio, why? Gio, no. Just stop. It's 1. It's 1. And then what is this 1 times -7? Oh, man. Let's write it down. -7. -7. Let's try this next question. -1 times 4 is?
4.
-4.
-4 plus 3. All right. That means P of -1, when I plugged in -1, this is still saying I'm plugging in -1. Let's go ahead and simplify this a little bit. 3 plus 5 is?
8.
8 minus 7.
1.
How would X for some reason?
1 minus 4.
-3.
-3 plus 3.
0.
Oh, yeah, there we go. Hey, look! The remainder is 0. Mr. Sindel just asked that conceptual question. What happens when you have a remainder of 0? It talks about whether or not you can, that is a factor. So is x plus 1 a factor? The
Yes.
answer is a capital Y-E-S, yes. And then the reasoning that you don't actually need, but I'm going to write down for our notes, and you're going to write it down with me. It's because the remainder is 0.
Whoa, what do you mean?
I'm going to add an exclamation mark because I feel like that's how I talk.
Got it.
Easy peasy lemon squeezy. Yeah? All you do is plug it in and see what happens. If I get something that's not 0, let's say, for example, I got, 123, then what would the answer be? Is it a factor?
No.
No, it has to be 0. A 0 means it's a factor. If I have a 0 for the remainder, and if it's anything other than 0, if it's even 0.001, it's not a remainder, or it's not a factor. Let's try example 2, and then we have a bunch more to go through. Example 2. I need to figure out the remainder when I divide this polynomial, this giant quadnomial, I guess, by this binomial x minus 5. I want you to do that on your own. It's a little bit hard, because you'll need to know what 5 to the power of 3 is. But go ahead and try this, and then once you're done, compare it with your group. Go ahead and try it. You're plugging in a positive 5 for this one. We're back. People have left to go talk about superintendent stuff, so we are now a classroom of 5 instead of a classroom of 8, unless you count Arrow in this classroom of 100 because she counts for multiple people since she's an AP Calc. All right, so I'm plugging in positive 5 into all of these, so it's going to be P of, I'm just going to go through it, sorry guys. P of 5 is equal to, do you just want to shout at me to tell me what to write? Negative 3 times what?
It's negative 245, and it's not because the remainder is down.
Okay, you jumped to the very bottom.
Wait,
I got
5 cubed.
Me!
Just shout it out. 5 cubed.
Wow, 125.
125, thank you. Plus 10 times 5 squared minus, what's 4 times 5? Why am I getting minus 100? What's negative 3 times 125?
325. 375.
10 times 25 minus 20 minus 100. That's still P of 5. And when I simplify all that, P of 5 is equal to what?
25.
Say it one more time.
245. Negative 245.
Okay, maybe we should do this.
125. It's minus 125.
So minus 100 and 250 will give me 150.
Wait, why are you doing it so weird?
I just go out of order to do whatever is easiest. Is that okay?
I did 375.
150, okay, shut up.
250.
Okay, 370, negative 375 and 250. We'll go left to right.
Isn't it 205?
That's negative 225. Or sorry, negative 125. Yes?
Yeah.
Negative 125, negative 145, negative 245.
205, right?
It's 245.
Negative 245?
Yeah. What?
Hold on. So these two combine, these two right here combine to become negative 125. Do we agree with that?
Yeah.
These two combine to become
Negative 20, 120.
I don't know what I'm right here. Negative 120.
Then you add those two.
Negative 120, negative 125 is negative 245.
It's negative 205.
No, 245.
How do you?
205? Not 205, it's 245.
It's okay.
I don't know.
Is that what you're getting, Eva?
Yeah, that's what I said.
Okay, just making sure. Therefore, our answer is no. No. Because the remainder is not 0. That is how I'm spelling it. Is not 0.
Whatever.
All right. Questions on the front. We're on to slightly new types of questions on the back. All right, here we go. We need to find the value of C so that this is a factor. So in order for it to be a factor, that means the remainder is, shout it out.
0.
Thank you, Eva. Yep, 0. She's carrying now that Andrea's not here. All right, so I need to set this thing equal to 0 after I plug in, what am I plugging in? Am I plugging in 2 or negative 2?
Negative 2.
Positive 2. 2.
I hear 2 2s, 1 negative 2.
2.
Okay,
2.
we're plugging in 2. Yeah, we're plugging in the opposite. The inverse of negative 2 is positive 2. So if I'm plugging in positive 2,
So true. Oh my god. I forgot about that.
Yeah.
P of 2, if I plug that in, I'm going to get 2 cubed minus 4 times 2 squared
Can you like
plus 2c plus 2. All I did was I plugged in 2 everywhere. Are we okay with this?
Wait, what did you do?
I plugged in 2. I plugged in 2, 2, 2, and 2. You are plugging in 2 as well. Notice that this thing becomes 2c, which is weird because you still have a variable. And that's the whole idea. We're going to solve for that c because we know that this thing needs to be equal to what?
2.
0. Let's go ahead and write that down. This needs to be equal to 0 because this is the remainder by the polynomial remainder theorem.
Wait, what do you gotta do for 2C?
2c, this was a 2 right here. 2 times c is 2c.
Oh, yeah.
Got it? All right, cool.
Wait, where'd you get 2C from? Oh, wait.
I just said.
Why would it be C2?
It can be c2 if you want.
I like C2, so it keeps.
All right, r2, c2. Okay. Now I'm going on to the next line. 2 cubed is 8. 4 times 4 is 16 plus 2c plus 2 is equal to 0. Simplifying this, 8 minus 16 is a negative 8. Negative 8 plus 2 is a negative 6. Negative 6 plus 2c is equal to 0. I'm solving for c. We have gone all the way back to our first, I don't know, month of Algebra 1. I think we can do this now.
So would you just move the 6 over to the...
Add 6 to both sides. Oh, careful. We're adding 6 to both sides, so I'm going to get a positive 6.
Oh.
Oh, so it's 3.
So C is equal to 3.
Tres.
C is equal to 3. Final answer, box it. Do you guys think you can try the next one on your own?
No.
It's a little bit more confusing because we have more negatives to deal with, but I think you guys will be fine. Go ahead and do that, and we'll be back in a sec. And we're back. Okay, so example 4, you guys are going to help me through this. What number am I plugging into all this? P of
-3.
-3.
Yes.
All right, we're going to take turns. So Eva just spoke, so Eva's going to let someone else speak. This is going to be -2 times what cubed?
-2. 3. Sorry.
-3 cubed minus
Oh, wait, sorry.
minus 8 times
-3 to the second power.
-3 to the second power plus 2 times -3 plus C. All right, so P of -3, that needs to be equal to 0.
Equals 0.
We can add the 0 up here, James. Thank you. -3 times -3 times -3. -3 cubed is
-27.
-27. That means on this line I have a -2 times a -27.
Which means you got minus 8 and 9. Negative 8.
-3 squared is
9.
9 times -8 is
72.
-70.
-72. Yeah. All right, 2 times -3,
That was
Negative
it.
6.
-6 plus
C.
C.
0.
Nice. All right, we're gonna take turns, Chris, too. -2 times 20, -27 is a
54.
positive 54.
Ah, this, guys, it's just the lighting.
Minus.
54 minus 72
Minus.
minus 6
Plus C.
plus C is equal to 0. Simplify this.
You got negative 18.
-24.
Tears in her eyes.
You got negative 18 minus 6. Negative 18 minus 6.
I don't want-
Negative 18 minus 6. Negative 18 minus 6.
Okay, we'll go with Chris.
Negative 18 minus 6.
It's not rounded.
Dude, you subtract 54. 54 minus 17. Where did you get 24? No, it's like, and then you subtract the 18. You gotta do the plus minus thing, right? Plus minus. And then you got negative 24 plus C equals 0. Then you add 24 to the other side, you get C equals 24.
Did that by yourself.
That was mean.
What?
24, is that what everyone else got?
Wait, how'd you get 3?
Oh, because
The first time.
I have no idea.
I think it was a mixture of errors from the negatives up here.
Yeah.
All right, and there's our answer. Are there any questions on the notes? All right, do your summary and then begin on Khan Academy.